Welcome back to our ongoing look at normal distributions and some of the things we have access to if we have a normal distribution. We looked first at z-scores, z-table lookups, and the standard normal distribution. We looked also at standardizing a normal distribution, where we would get a z-score from a set of x values and a mean and a standard deviation. And now let's start looking at some things that can be made into a normal distribution. In particular, we're going to look at sample distributions and how we can estimate something. So a big question that we have in statistics is, what is the population parameter? Right? Something we've said time and again throughout this semester. If we have all the data, it's not a statistic anymore. If we have all the data, it's a parameter. A parameter is based on the entire population. So if you want to know what parameters you have, you could measure everything. And that'll do it, right? If you want to know the mean height of everyone in the country, you could measure the heights of everyone in the country. And then you would have the parameter. Of course, that's going to be more trouble than it's worth. So most of us will be content to just take samples. And one thing we'll look at, not this chapter, but the next, is how many people do we need to measure. But anyway, we will verify in this video series that if we can get enough of a sample size, we're going to get accurate measurements of the population mean. So that's a parameter we can get. We can get proportions, and we can also get variance. And of course, if we can get variance, we can take the square root of that. We'll get standard deviation as well. And these are all things that we can get for an entire population without having to measure the entire population, which is pretty good. In fact, we can do maybe a few thousand data points to measure millions. And we'll see how that goes, not just in this video series, but that's going to be an ongoing discussion into the next chapter. So what I want you to get out of this particular section, this particular series, is two big pieces. First of all, I want you all to notice that if we're taking multiple samples, the statistics that we take from those samples will be normally distributed. Well, certain of them anyway. Hint, by the way, our hint is it's probably going to be for means, proportions, and variance. But those statistics will be normally distributed across multiple samples. Also, and this is key, the means of those statistics will approach the parameter in question. So if we have a lot of samples and we take the means of their proportions, for instance, then the means of those proportions will equal or at least approach the population's proportion. And we'll talk about what that is here in a second. If we take the means, or rather we take the sample means and we get the mean of the means, that mean of means will equal or at least approach the population's parameter mean. Same for variance, same for standard deviation by extension. And we'll see all of that in this video series. So before we get into that though, I do have a question for you. What is a sample? What do I mean when I say sample? A sample, of course, is just a piece of the whole puzzle. It's a piece of the whole picture. It can be any partial list of the data taken from the full population. It's what you know. And it can be a single number. It can technically be all the numbers, but it is simply going to be an incomplete list. And so if you polled 10 people, you have a sample of size 10. If we did 3 random households, we have a sample of size 3. And of course, if I flipped a coin 5 times, recorded the results, I'd have a sample of 5 numbers. And then you could do that, and you would have a sample of 5, right? Any sample is random and incomplete, generally. You could technically do it for everybody, but anyway. So the question I want to end up with is, would we rather do one big sample or a whole bunch of little samples? And honestly, it doesn't matter which. The one we're going to look at in this section, though, is a lot of small samples. And we're going to turn those into a big picture. So I'll stop here. We'll talk about the law of large numbers in the next video, and we'll go from there. I will see you then.